So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. To start off, we're going to play a little mood music to set the right tone for today's show about solar inverters. Now remember, solar inverters convert DC into AC, and this clip may explain why there's so much solar power in our... So, high DC voltage comes down from your roof, typically about 350 volts, but sometimes up to 600. That's on a home. And these are all things that are permitted by electric code, and we're very careful to make sure the systems are designed safely. Now, that high DC voltage is then converted into 120 volt AC power that you use in your home or your business. So basically, everything we plug into the wall uses AC power. But batteries and solar panels generate DC, so we need to convert it from DC to AC, and that's what the inverters do. Now, there's lots of changes recently in the inverter business, and all of these changes are making the inverters both safer and less expensive, and they're also getting more efficient. So it's great to see how technology is improving the solar industry. There are three basic types of inverters that you'd put on your home solar system or your commercial solar system. And this also generally applies to large industrial or utility scale. The first type of inverters are string inverters. Now, these are the basic tried and true inverters. They've been around for a long, long time. When I started doing solar installations back in 2000, 2001, string inverters were the standard. The second is relatively new. They really started coming onto the market in 2009. These are microinverters. So instead of one big inverter, you have little inverters on the back of every panel. And the last innovation, and these innovations take time to filter into the market, are string inverters with optimizers. And these optimizers go on the back of the solar panels or on the racking, and that gives you some additional advantages. We'll talk about that in a minute. So what does all this mean for homeowners? Well, I'm going to give you my recommendations now so you don't have to listen to all the geeky talk later that's going to be of interest to solar installers, unless you're a geek like me, and then you're going to want to listen up, and if it's nighttime, it's going to put you to sleep. But anyway, here's what I recommend if you're looking at solar for your home. Number one, find an installer that you trust. Generally, the installers have a preference for the equipment that they install. And the most important thing is to find a good solar installer, somebody that's going to be around, that's experienced, that's going to be able to put in a safe system, make sure it's going to last, and maintain it in the future. Okay, so as far as your inverters, as I mentioned, there's three basic choices. The standard string inverter is the least expensive inverter, and it's really good if you don't have a lot of shade or like weird objects like chimneys or trees that are going to partially shade the system. They're good also if price is a key consideration for you. And it's also good if you don't require panel-by-panel monitoring. Now, this is a box that's the size of like a microwave oven, a little bit flatter. It's going to go on the side of your house somewhere, or often somewhere in the basement or your garage. So you're going to have that thing stuck there, and then there's going to be conduit or wires that go up to the roof. Your second choice is kind of a hybrid. It's a string inverter, like the same inverter on the side of the house, but there's optimizers. These are little boxes of electronics that go on the back of the racking or go on the back of the panels that are going to improve the performance of the system. These optimizers give you more system flexibility, and they're safer than just string inverters because they eliminate some of the high voltage arcing that could happen, and they give you some additional rapid shutdown capabilities. And they also give you panel-by-panel monitoring. You've got electronics on the back of every panel or operating every panel, and you can monitor that panel, and you can make sure when it's working or not. Now, the cost of these string inverters with optimizers is a little bit more than regular string inverters because you got a little electronics on the back of every solar panel. The third option are microinverters. These are the most elegant solution, and this is basically a miniature inverter the size of a paperback book that goes on the back of every panel in an AC panel or goes on the racking that's underneath each panel. Now, these microinverters are safer than plain old string inverters because they convert the DC into AC on the roof under each panel, and you don't have any high voltage ever. Any high DC voltage ever. It also gives you panel-by-panel monitoring. You don't have a bulky inverter on the side of the house, which a lot of people like. It's a cleaner installation, but they're usually more expensive. So, as I mentioned, installers often have a brand preference for what they install. At Cinnamon Solar, we install standard string inverters for our price-sensitive customers, and I love these things. I've been installing them since 2001, and they had a 5 to 10 year lifespan, and we're kind of, after 15 years, we're replacing a lot of them, and we're replacing them with similar string inverters, actually from the same manufacturer. Really, really reliable. Second option are microinverters, and we install those for some customers who really don't want to see the inverters on the side of the house and prefer that kind of design. But the microinverters are kind of that premium, higher cost option. Most of our customers at Cinnamon Solar, we install string inverters with optimizers. That gives us the most flexibility, it gives us the best safety, and it gives us an upgrade path to battery storage, which is something that we're going to talk about a little bit more later on in the show. All right, so let's dive into some of the details of these microinverters, string inverters, and string inverters with optimizers. So, string inverters. Probably the most established and the most reliable string inverter company is a German company called SMA. They've been around for a long time. I've been installing their inverters since 2001. They're great. A few other inverter companies that have been around for a while, Fronius, Keiko, and now there's some very new low-cost entrants from China and Asia that make really, really good electronics. They're just fairly new, and their costs are lower. So they're, for people who are really looking to save a buck, maybe these Chinese inverters are a good option. From a performance standpoint, I'd say that all the inverters are about the same. Some things to look for with string inverters, and this is something that's going to resonate for the installers listening in. So you want to get string inverters that have several maximum power point tracking inputs. Now, these are the inputs on the inverters that actually modify the voltage and the current that goes through the string of solar panels so you can get the most power out of it. Standard old inverters have one maximum power point input, but the newer inverters have 2 or 3 power point inputs. So, for example, if you have a house and you have an east roof and a west roof, let's say you put 10 panels on the east, 10 panels on the west, you want to optimize those panels separately because they're going to get different levels of sunlight. East panels going to get a lot of sun in the morning, west panels, a lot of sun in the afternoon. So that multiple inputs is really, really helpful. It also helps if one string gets shaded, then it's not going to pull down the rest of the output of the system. Another new feature on some of these string inverters is what's called a secure power supply. So SMA offers that, and they have a little output on the inverter. It's a little bit of an extra cost, but you can connect up to 2,000 watts of anything you want. Little mini refrigerator, if it can handle it, charge up your cell phone, charge up your batteries, things like that. Now, the output from this really depends on the amount of sun. So the output can be up to 2,000 watts, but that's only if there's a lot of sun hitting the panels. Ordinarily, you might be able to just pull maybe 300 or 400 watts out of it because it just depends on the sunlight. We're not talking about batteries, so it's not going to work at night. It's just good for a few gadgets that you have to charge up when the sun's hitting. Another good thing that a lot of these new inverters have are DC disconnects that are integrated, so it makes the wiring easier. I'm really glad that the inverter companies are thinking about making it easier for installers to wire these things up and connect them on the roof. Next option that's been out, kind of the next technology version was microinverters. Enphase, company in California, pioneered the concept of microinverters, and I've been using them since 2009. They're great. A few new companies. APS is another new company based in California and China. They make good microinverters. Some of the features of these new microinverters, they have new cabling designs. Once again, we're talking about making things easier for the installer. If it's easier for the installer, they can charge you less money, so I like that. Now, they're also finally making microinverters small enough that they can attach on the back of the panels without extra hardware. SunPower, by the way, has an integrated microinverter. They have an AC module. They bought the assets from a company called SolarBridge. Enphase also has announced a similar product. And, by the way, I'm a big fan of AC modules. At Akita, we started shipping the first AC module back in 2009. It worked great, but back then it was too expensive. Now they're much more affordable. In the future, I expect that these microinverters on the back of the panels are going to replace the junction boxes, those little black plastic boxes. But it's a tricky mechanical issue. They have to be small and lightweight. Finally, the kind of the newest innovation, although they've been around for 5+ years, are string inverters with optimizers. SolarEdge right now has the best system. They have got their own inverters that are designed for their own optimizers. So they've got a complete system. Tigo, another California company, is similar now that they have partnered with SMA. So both SolarEdge and Tigo have some pretty cool products there, and I really like the fact that Tigo teamed up with SMA. Now, the other innovation that's happening is the optimizers are replacing the junction boxes. So there's less field labor. We don't, as an installer, have to install this optimizer on the back of the panel or on the back of the rack. It just comes built into the solar panel. That's really great. Now, 3 most important characteristics of inverters, assuming they're code compliant and safe. First, they have to be reliable. And all manufacturers have good warranties, and all have honored these warranties. Second, they have to have good efficiency. Efficiency 15 years ago was 92%. Now it's pushing 97 or 98%. Keep in mind, you can't get any higher than 100%. So 98% is pretty darn good. It's not worth paying a ton of money to get to 99. Finally, cost. It's both the purchase cost and the installation cost. And when you think about the installation cost, you also have to think about the monitoring that comes with it. And some of these systems are kind of clunky to monitor or flaky to monitor. So as an installer, I'm looking at a low purchase cost and a low total installation cost. Now let's talk about some of the new and cool features on these inverters. But first, before I talk about the specific features, I'm an engineer. I develop products, and we install a lot of products over at Cinnamon Solar and Spice Solar. It's complicated and expensive to add features to any product. You got to do it right. It takes a lot of testing, and sometimes it takes years, literally years, of Underwriters Lab UL certification work before you can go into manufacturing and sell a product. Now, that's one reason why these inverters and electronics are expensive. There's a lot of R&D, there's a lot of testing, there's a lot of manufacturing technology that goes into them, and that's all expensive. A lot of times there'll be these new innovations, and they won't come out right away, or a company will say, we're going to come out with a new feature, but sometimes it takes them 2 years before they get that to the market. The reason is the feature probably works, but they have to go through all the internal testing, manufacturing, and the UL certification before they can start selling it commercially. And the UL certification is important because that's where they go through the testing and making sure that it's safe to put in your house, in your roof, or in your business. Okay. Now, let's talk about some of these specific features. One of the features that the people started talking about 10 years ago is something called arc fault protection. When you have high voltage DC and you take that 300, 400, 500 volts and you take 2 wires with that, you're going to get an arc. It looks like a science experiment. Very, very high voltage, very high current, really hot. It melts the wire. So those little arcs, if they occur, if there's a loose wire, it can actually cause a fire. So this arc fault protection system detects when there's an arc, there's kind of an uneven current flow, and it shuts down the DC current in the system. And that reduces the chance of a fire. And I've seen a few fires on improperly installed systems, usually on commercial. This arc fault protection requirement came into the National Electric Code in 2001, and it wasn't until a few years later that pretty much all the inverters on the market had this arc fault protection circuitry. So if there was a DC arc, for example, on a commercial system, or let's say that a squirrel was gnawing on a couple of the DC wires, well, it would detect that arc and it would shut the system down. It's a nice safety feature, and probably saved a lot of squirrels' lives. All right, next big industry safety requirement is something called panel level rapid shutdown. And what this is supposed to do is if there's a problem with any given panel, or if the system needs to be shut down, every single panel is going to shut down and you won't have to worry about any high voltage in the system at all. Now, here's why it's important. Ordinarily, let's say you have 10 solar modules on your roof and each module puts out 35 volts individually. When you have those 10 modules in series in a string, you got a total of 350 volts. And as we talked about with arc fault protection, that can be dangerous. And the reason why it can be dangerous is if there's ever a fire or if somebody has to work on the system, particularly if there's a fire, and this is where these requirements came into effect, the firefighters wanted to make sure that they weren't going to be stepping on any high voltage. They weren't going to be pounding an axe or spraying water on anything that would really have a high voltage. So it's a great safety feature for firefighters. And so this requirement started to come about a few years ago, and now there are some products that have this kind of capability built in. It's a great safety feature, and basically what it does is it prevents any high voltage happening in the system. You turn the system off, one switch, and the inverter would automatically shut down all the individual solar modules. Now, in order to do that, you need to have electronics in every single solar module. So that means you need to have either microinverters, because each one's going to shut down when it doesn't have its reference AC voltage, or you're going to need optimizers on every panel, and those optimizers are going to look for a signal from the inverter, and if the inverter's turned off, that signal's not going to be sent up to each optimizer, and the optimizer is going to shut down. So, for example, systems that we've been installing with microinverters since 2009 shut the power off to the house, no AC voltage, all the panels are kind of dead. With optimizers on the back of those panels, you shut the power off to the house. The most voltage you're going to get out of each panel with an optimizer is about 1 volt, totally safe. And this became a code requirement in 2017, and now pretty much all the systems that have microinverters and optimizers have this built in. Companies that make regular string inverters are working on add-on components that are going to be able to provide this capability. Okay, next important feature, monitoring. Heck, since 2001, I've been putting in systems that have had some kind of monitoring. Really clunky at the beginning. You'd have to run an RS-45 wire to a tiny little circuit board that would be outside the panel, and it was difficult to do, and there was a separate box that you'd have to put in. And now, a lot of the inverters and all the microinverters and optimizers have good monitoring capabilities. Usually they have built-in Ethernet ports. Oh, great, just plug an Ethernet cable in. Or they have easy wireless LAN connections, and in some cases with Zigbee. So they can go wireless, or you could plug a cable into the inverter. Now, the reason why I generally don't like plugging a cable into the inverter is the inverter's outside your house. Now I got to get a Cat 5 or a Cat 6 wire from inside the house where the router is, or the internet connection is, through the wall, around the house, into the inverter. And you're going to have a little wire there that's not going to be as durable and lasting as wire that's in a conduit. So it's a little bit clunky, and I kind of like wireless connections, Zigbee connections, or ideally the best thing that's out there now and that we're really happy to be installing are cellular connections. So the inverter actually has a cellular modem. So there's no connection at all to the home's internet service, and there's advantages to that I'll mention in a second. So that the inverter sends its data up the cell system to the inverter company's server, and then you can access your data that way. So there's absolutely no wired connections at all. And the reason why I like cellular connections is, in my experience doing monitoring for over 15 years, our most common cause of service calls and the biggest pain in the neck service calls all relate to monitoring. The system's working. The modules are working. The inverter's working. Something's flaky with the communications. Somebody's Ethernet screwed up. They changed internet service providers. Somebody unplugged an Ethernet cable. There might be noise on a power line carrier. And then we get the call, come over and, our system's down. And it's an IT problem. And that's expensive for anybody to fix. So I really like cellular communications because they just work more reliably. Next feature, and it's not really a feature, it's just kind of the trend, and it's really good. The pricing on systems has been coming down steadily. The inverter pricing used to be $3,000 for a small string inverter, over $1 a watt. Now it's less than half that. And the new inverters that are coming in from overseas are even cheaper. So we're seeing also, in addition to reductions on regular string inverters, we're seeing similar reductions on microinverters. The pricing has come down a lot, and that's really good. And we're seeing similar reductions on string inverters with optimizers. Now, as an installer, I just don't install the inverter or the microinverter. I also have to install the cabling, the gateway, any kind of interface boxes, etc., and all the labor that's involved. So as installers, we're always looking at this holistically. It's not just the price of one, $1,400 inverter. It's all the time and labor and accessories we need to install that. And so I like the fact that a lot of the inverter companies are thinking about it from the installer's perspective and trying to find a way to make that installation easier. And some of the ways they're making the installation easier is they've got built-in disconnects. They have built-in features like Ethernet ports, which is great because we don't have to kind of put in a custom circuit board. The inverters have come down a lot in weight. The standard inverter that I installed in 2001 weighed 65 pounds. It was just like a toaster oven size box of electronics that weighed a ton. It was like a workout, lifting it up and propping it up against the side of the wall and bolting it in. Now the inverters are much lighter weight. They use new circuitry, and that makes the installation a lot easier. I also mentioned that the monitoring is better. And I like cellular monitoring, so spend a little bit more on cellular monitoring. I'm happy to do that, and the installation and the service costs are going to go down. Now, another key consideration is future battery storage considerations. Now, no doubt, in my mind, at all, that battery storage is going to be a key part of rooftop installations in the future. Most solar installations on the roof are, in the future, going to have battery storage. But that future, in my view, isn't quite here now. A lot of people want storage now. There's two problems with storage systems right now. The first is that most electric rates provide no economic incentive at all for battery storage. That's in the U.S. Australia has benefits. Hawaii, actually, is the one state where there are rates that are good for battery storage. But in general, the economics aren't there. Second, the batteries, the control systems, and the software are still expensive and complicated. It kind of reminds me of PCs in 1980. I mean, they just started coming out with a box that did everything with software that was kind of okay. So there are some companies that sell complete battery storage systems now. I like them. They work, but they're still somewhat complicated and expensive. So my recommendation, if you want to be at the bleeding edge, I can point you to a bunch of good battery storage companies. Adera makes something pretty good. SolarEdge has some storage capabilities with their storage system. Enphase has a battery storage system. There's a bunch of them out there. But my recommendation is, if you don't want to be at the bleeding edge, wait a few years. Battery prices are going to come down a lot, no doubt in my mind. And you're going to get software and accessories that are going to be better. So buy a system now that is battery storage ready. Some inverters can be easily upgraded for storage and for backup power. Some can't. So make sure you get one that can be easily upgraded. And your installer should be able to explain how storage is going to fit into your system in a few years. So, recommendations about inverters. First, find an installer you trust. Second, string inverters are good. I've been using them for 15 years. They're reliable and relatively inexpensive. Microinverters are also great. They're more expensive than string inverters, and they may be tricky to install with battery storage in the future. And finally, string inverters with optimizers, probably the best compromise right now for performance and price, and they have good battery storage capabilities in the future. All right, well, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in, and if you missed any of today's show, you can always go to our website at cinnamonsolar.com and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.